the reality is 80% of network outages are caused by either human misconfiguration or human issues or through change management issues. And this was shown from Gartner. So what does that mean? I put a new application in, I didn't do a total interoperability with the other applications that are out there. I have an outage because of that. I have a new engineer that's going to install a component as we grow out our infrastructure, and they misconfigure a device that creates an outage. That's really where most of our outages occur, how most of our outages occur in the networking side. So you have to look at the mundane, and then you take it all the way to the extreme. The extreme, what we talked about with our, whether it's man-made or natural disasters that can totally shut down a data center or a campus. And you have to look at the whole spectrum there and be prepared for that. So these scenarios, I'm only going to just briefly talk on a few of them because there are hundreds or thousands of them that you should plan for, but I'll talk on a few and kind of give you an example how this can help you. So if a very mundane cause of an outbreak or an outage is that engineer who misconfigures the router. The router is down, what do we do? Well, how do I address that? That's a pretty simple one to fix. That's really a process and best practice, right? And when I talked about products versus process, most of those are addressed in process. Mundane are typically addressed by fixing your processes, reviewing them on a regular basis. And it doesn't have to be a 900-page standard operation procedure. Take it to the next level where I now have a backhoe who pulls up one of my fiber links, I think was brought up earlier. How do I work around that? We have tools in technology that can do that. We have redundant links. We have a way of higher level protocols addressing the automatic reconfiguration of our infrastructure. So an impact of a fiber cut, any type of network attack should be addressed within the network and automated, and should be no impact to the user. If a system is either overloaded or not meeting its performance, we have ways of the network to look at the load balance that server or that service with other services. So I can actually move users from one server to another on the fly automatically. Now I could do that within a data center, or in the case of a data center failure, I can actually have the infrastructure do that across states, across countries if I need to, using a global site selector. So the network has a play in terms of helping redirect users' access to applications. And we spend a lot of time in designing those type of networks for our customers in the federal agency. And it's important. We also have the other scenario is if I lose my data center, I have to somehow get that data up and running. And in most cases, as we talked earlier today, it's more of an active scenario than it was nowadays than it ever was, because we have the capability and technology to do that, leveraging the lowest level DWDM fiber channel on top of IP, so I can get beyond the very short distances of fiber channel and other technologies that can help me deploy these active data centers. So it's important that you look at application resiliency as well. Well, most agencies still, on the civilian side, their primary means of communication with the citizen is through the telephone, right? Whether it's a call center of some sort or calling directly into an agency. Well, how do you ensure that that call center is up all the time? So as I said, 40 years ago, we took packet networks and made data, we abstracted data from the physical level. That's happening now with voice over IP. We're taking voice networks which were circuit-based, and because they were circuit-based, just like data networks were 40 years ago, they were constrained by a physical location. In putting voice over IP, I now have the abstraction of the physical from the actual voice, which becomes an application at this point. So now I can have that call center distributed across the country, and distributed within a city, across country. We can have, and when you do that, you obviously add resiliency to your communications platform. So that's one way of adding communications resilience. Another way we saw with and I think someone brought this example up earlier, because of Katrina. So what happens in the scenario where, when there is a disaster? Well, the first thing you want to do is get situational awareness. How do you get situational awareness? You pick up the phone and call them. Within Katrina, what happened, obviously, there was no infrastructure. So what was that disaster recovery model to provide an infrastructure quickly? Again, unified communications or voice over IP, we can do this rather quickly, and we did this with FEMA as well as the National Guard, giving communications real time on the fly by putting in voice over IP and then leveraging, because it abstracts from the physical, I could use Wi-Fi technology, WiMAX technology, or even satellite technology to add that service to the population when I needed to.